Dr. Piotr, which he studied experimental physics in London, and for his PhD, he focused on biomaterials to self-assemble inorganic materials. So for me, it sounds like he's basically creating cyborgs, but I heard it's more about like creating biological sensors. And yeah, recently he started focusing on AI engineering. And yeah, in his talk, he'll tackle the problem of training AI models with data that contains private information. So how do you train data that you really shouldn't expose to the public? So how do you avoid ChatGPT giving you the address of private people? So yeah, the solution is probably replacing it with something else, but how do you replace it, and how do you ensure that you really replace everything that's private information? I think will explain to us. Thanks a lot, and welcome, Piotr.
Thank you very much. So my name is Piotr. I'll be talking about the anonymization of sensitive information in financial documents, medical documents, using Python, diffusion models, and named entity recognition. So to keep it simple, what I'm going to talk about is how to get from that document to that document. So to identify what the P2 information is, specifically names, addresses, bank account details, and then remove them and replace them with synthetic analogs. So you have the second document, which looks just like the first document, but doesn't have any of the sensitive information in it. The reason you want to do it this way is because you want to keep these documents for training and benchmarking AI models. So data is a new oil. Machine learning heavily relies on good quality data. There's a really good talk by Eric Schmidt where he argues quite persuasively that the next $100 billion companies will not be based off AI models, but based off data, specifically if data is niche or specialist. So all the large language models at the moment, they're initially trained by scraping off the internet. But if you can train, and so they're able to do things where their data is within distribution. So they struggle to do things which they're not trained on. If you have data which can't be scraped off the internet, that gives your company an advantage. And he argues quite well that that's the advantage to a company. Now, I want to get across why this data is so important. Let's say you work in mortgages, so you're a bank that takes mortgage applications. If you've ever applied for a mortgage, you've got to supply bank statements, mortgage statements, or for previous mortgages, pension certificates, ID cards. Now, I know we're based in Switzerland, but people move from Germany here, from Poland. So if you're ingesting all these documents, you're going to get a lot of weird and various documents from across the continent. And if you're training AI models for extraction, or for example, the various amounts from tables, from charts, you need to have this kind of wide range of data in order to be able to train your extraction models. And you can't normally keep these documents because they contain P2 information. So the trick is, of course, remove the P2 information in a systematic fashion. There's 3 stages to this. First is identifying what the P2 information is. That's used using a technique called named entity recognition. 2 is masking or synthetic replacement. And 3rd is using a diffusion model to correct the image so it looks like the original, but of course with a synthetic replacement. So I want you to take a look at this picture and tell me what's wrong with it. I asked ChatGPT to draw a picture of Europe, and this is what it came up with. So initially, it actually does a pretty good job. Like the borders look pretty good, but of course it's messed up some of the names. And what I want to get across is you can't use ChatGPT to do this. You can't use it to do anonymization. Not just because it gets things wrong, but often because it's hosted by somebody else. So this presentation, I specifically structured in such a way, I did not want to give another talk which is about ChatGPT or LLMs. I wanted to give a talk about tools that you can self-host and something that's a bit different. So step one, identifying the P2 information, i.e. name entity recognition. So the three simpler techniques are regex, spaCy, and using something like layout LLM. These all require a pre-OCR layer. So you get your PDFs, convert them to images, and then you OCR them and then feed them into that. Don't rely what's in a PDF, because sometimes people scramble the text that's overlaid onto it. Make sure you convert to an image and then OCR it. Now, in terms of these techniques, they're simpler, but they're also fast. Regex is really, really fast, and it actually does surprisingly well on things like IBANs and phone numbers. Of course, it won't do well with things like names or addresses. spaCy is incredibly powerful, and my strong recommendation is to always start off with spaCy as a base case. It's an awesome open source project, and I can strongly recommend it. Then, the limitations of the techniques that require the pre-OCR layer is what happens if you've got a damaged document. Say you've got a document where the IBAN is a bit smudged and it doesn't OCR the IBAN correctly. The techniques such as regex and spaCy, because they rely on the text, won't do as well, which is where the more powerful techniques come in, so the OCR pre-transformer models. But they're, of course, a lot more complicated. You can experiment with fine-tuning. My strong recommendation is always to start with spaCy and then move on to a more complicated technique. Use spaCy as a base case. It's okay to over-anonymize. The worst thing you want to do is under-anonymize and miss something. So great, you've identified your P2 information and you just black out the text that you're working for the KGB, right? You can do this, but the problem is that you damage the underlying document. Essentially, you take your data out of distribution. And this is really, really bad for machine learning because how sensitive the machine learning process is to the underlying data. There's a classic paper from about 10, maybe 15 years ago when convolutional neural networks were getting quite good at classification, where they demonstrated that they could classify what's in an image better than most humans. So, is it a cat? Is it a dog? Is it a fish? When they did exploratory AI on the actual underlying models, like where do you look in the image, they found for their fish models that when trying to recognize what a fish was, it was actually looking at the fingers and not the fish. They then looked into the data, and it turned out that most of the data was basically people holding fish. And that's why the model had learned to recognize fingers and not the fish. So this is why I strongly want to advise you against altering your documents in this way. Machine learning models can do weird and exotic things and start to recognize the damage you've done to the documents because you've taken them out of distribution. So what's the solution to this? Diffusion models. So diffusion models are models which are trained by adding Gaussian noise to them, and they're taught to denoise the images and reconstruct them. So a naive approach is to just download Stable Diffusion 2, plug in a bounding box and a replacement text, and this is what you get. So it hasn't done too bad at the bottom one. The font is roughly consistent. It's messed up the font and looks really bad at the top. But there's a couple of serious issues. Firstly, I've asked to replace the text Adam Jensen with JC Denton, and it's messed up both essentially. The in-text replacement isn't correct. Secondly, if you notice underneath where the address, so 32 Kenwood Avenue, that S2 Ken Avenue and 52 Ken Avenue, is gone and it's altered the surrounding bodies, which is not what we want, especially for training extraction models. We want to anonymize the person's name, but maybe not what is around the name or below the name. The reason Stable Diffusion has done this is because it's been trained this way. If you've ever sort of been as a teenager and tried to Photoshop a cat into a new picture or person, the sharp boundaries look really, really weird. So Stable Diffusion has been trained to correct this. And obviously that doesn't work well with raw text. So there's a couple of papers out there which do this, and there's a lot more coming out all the time. What we did is we reproduced a paper by Ant Group called diffusion. So what I'm going to go through is our reproduction of this paper, the results we got, and how this paper basically enhances Stable Diffusion 2. So Stable Diffusion 2 is based on 3 components. The core engine is the UNet, so that's what does the denoising process. This is computationally extremely expensive. So before that, there's something called a variational autoencoder. This takes an image, it compresses it to a reduced dimensionality, what's called latent space, and then is able to reconstruct it. Think of it approximately like a form of lossy compression. So this essentially, because it's able to take an image, convert it to a reduced dimensionality, the UNet requires less computational power to operate, and then it reconstructs the image by the UNet. The third is the conditioning layer. So they use open clips so you can condition how the UNet operates, i.e. that you can tell it to include text or images. And this is vanilla Stable Diffusion 2. Where the diffuse paper did is they replaced open clip with TR-OCR, so it's an OCR engine, and directly hooked the embeddings in. They then retrained the variational autoencoder and then the UNet. So the variational autoencoder is basically a process which takes an image, converts it to reduced dimensionality, and then reconstructs the original image. So it's an efficiency trick. We have to retrain it because Stable Diffusion 2 is trained on natural images, so cats, dogs, birds. Those tend to have very sort of soft outlines. Text is quite sharp and has very sharp boundaries. So we have to retrain this first so we can reconstruct text correctly. Then we retrain the UNet. So we take 3 variants of the underlying image, a masked image, and an original noisy image. We select a region of text that we want to sort of reconstruct. We re-inject, we concatenate, we encode these into a latent space, concatenate them, and feed them to the UNet. We then feed the original text that we've masked out in, and we try to get the model to reconstruct the original image, and we create a training loop based off this. What I really liked about this paper is that it had self-supervised learning. Essentially, you don't just have to take the P2 information for anonymization for training, you can use any bit of text. So you go from one bit of text, another bit of text, another bit of text. And this strongly conditions the model to behave exactly what you want, the way you want it, i.e. to reconstruct the original text and not the surroundings. And to also compensate for more complicated backgrounds. So for example, if you have a bit of text on the blue background. Inference is just like training, except we fixed all the model weights. So we take the original image, apply a masked image, and a noisy original, convert them to a latent space, concatenate them, but instead of the original text, we add a replacement, so JC dented in this case, and this does the inpainting. So for simple documents, this isn't too bad, right? So it's correctly sort of changed the person's name, the address, also the person's name down there. The fonts look similar. The alignment's a little bit off. I could probably do slightly better with Photoshop, but I couldn't automate this at scale. And of course, it's left the other things in place. So it's left the balance sheets, transactions, all these things have been left alone and not modified. Where this technique really becomes powerful is for complicated documents. So it's done an alarmingly good job on an identity document. Quite happy sort of filling out the background line. Obviously, it hasn't changed the person's face because it wasn't designed for that, but it's done a really nice inpainting of the identity document. So limitations of editing. It's you can't anonymize people who are high net worth. If you're the King of England, the bank statements are too unique. Also, if you're doing editing, make sure that the editing you do, that the text that you replace is about the similar length. So the person's name is similar in length to the synthetic. It's also important within that same document to keep the same person's name that's being replaced, and probably gender or titles also should be consistent throughout the document. So in terms of improvements, so I've been experimenting with trying to improve the training process by adding in this paper. So they claim that you can improve the variational autoencoder with a 45% increase in performance, and I'm still experimenting with that. To give you an idea of how much it took to train the original code, so it took about 3 days on all 490 GPUs to train the variational autoencoder, and the same, so three days on 490 GPUs for the UNet. That's how much in terms of computation we used. So to summarize, I wanted to get across just how important data is to machine learning, and that how important that you can't train good extraction models without large amounts of data, especially if you're working in domains where you get various different documents from various different sources. That there are 3 stages to this. There's using named entity recognition to identify the P2 information. There's synthetic masking, and then you can use diffusion models to do the inpainting. So, as a speaker, usually what happens is that we prepare next year's talks. It takes about a year to prepare a talk. So I want to quickly mention what I'm preparing for next year's talk. First, I want to thank the organizers. Thank you very much for organizing the conference. It's a huge amount of effort to organize a conference, and thank you for inviting me. And then what I'm planning for next year is I'm probably going to focus more on defense tech. I live in Warsaw. We had a very unpleasant incident about a month ago where drones came in. What I want to get across is that I'm going to be working more over the next year in terms of image and acoustic systems for recognizing drones, and that's what my next year's talks will be about, because drones are real bastards. This is actually off a Russian Telegram channel targeting infrastructure in Ukraine. And what makes these drones so nasty is they're about 400 euros to build. If you're interested in defense tech, there's a hackathon happening in Switzerland, or if you're a bit more braver, join me in Kiev. I'm based in Warsaw. Add me on LinkedIn. Any questions?
All right, we have quite some time for questions. So are there questions in the audience? There's one over there. Hi, Stefan.
Hi, thank you. So when anonymization takes place, right, do you keep the relationships? So do you replace, let's say, one name always the same synthetic name, or is it at random?
You do it consistently within the same document.
So over many documents, you do not keep the network that links people.
No, that's too much. So within the same document, you want to do that because you want to basically be able to train extraction models. Or let's say, okay, I as a company can't compete with Microsoft, for example. So I'm going to use their models, but I want to test against their models and how they reason against the document. So I want the synthetic to have the same approximate consistency. So if it's going to reason across the document, you want the same synthetic name in the right places so it can give you the correct answer that person XXX did this, for example.
Thanks.
All right, there's one more question there in the middle. And then another one there, and another one. Oh, cool, lots of questions.
So first of all, thank you for the very interesting talk. Maybe it's a nitpicky question, but so you talked about you don't want to introduce biases in your data sets. That's like, totally get that. So when I saw the document earlier, I saw there were like small indentations in the name and so on. Could that also be a problem that, so when I would do that for millions of documents, that this type of behavior of the stable diffusion could also then be learned by like a different ML model that tries to do like certain classifications? So
yes, it could.
Exactly. Okay.
So it is a defect in the anonymization process. Ideally, you want to correct it. And you're absolutely right. Models can do weird things and start to learn shifts like that. But it's better than the alternative, which is black boxes.
Definitely true.
All right, next one is over there. If this one is closer, yeah, it's okay.
Sorry, you are next. Okay, cool. Thanks for the talk. Really nice, and welcome to Switzerland from Warsaw. So basically, I just want to understand. So because you are saying that it's very important to keep the structure of the document, yeah. So that's why you're making this anonymization. But then, could you elaborate more? Then, what are the ML tasks that you do on these documents? Yeah, what kind of predictions you are trying to do for which keeping the structure is so essential?
Okay, let me go back.
Yeah.
To these. So here, so this should give you an idea of what you want to extract. So let's say I want to automate a pipeline where people are applying mortgages, or one bank sells a mortgage to another one, right? So instead of somebody checking things, I want to extract the name, PESEL number of the Polish ID document. If it's a Czech passport, their ID documents. If it's British tax statement, then the date information of that. So on and so forth. You want to extract all this information for compliance reasons. Does that sort of answer your question?
I'm just, trying to understand, like, if I extract this information for compliance reasons and then I extract a fake name, so then what is the compliance?
Oh no, so that's you partition essentially the original documents and your synthetics, right? So that you've anonymized, right? So when you've got a separate data set which is completely anonymized, you can train and extract off that and validate. So if you extracted the fake name, that's fine. It means your model works exactly as you want it to.
Okay, good. Thank you.
Right, so over there.
Thank you from me as well for the great talk. I don't think I've seen this kind of problem before. What I find fascinating is that the variation you need in data here is not across samples of the same kind of document. You need variation across the formats that you obtain, right? And also the inference is only useful if you get lots of different documents in different formats where you need to extract that. And I was wondering sort of what kind of organizations would be doing this? Because normally if you're an organization and people apply to you or they hand something into you, you'll have some level of standardization, most likely. So why couldn't you just build a simple name entity recognition pipeline to get the information you need from the few formats you have?
That's often like a naive assumption when you start working with data. Turns out the data is always more complicated than when we start working with it. Like for the EU, for example, because there's freedom of movement, you get people moving in. So I understand, like, let's say you want to apply for a Swiss mortgage because you're Swiss out here. The bulk will be Swiss identity documents, but maybe it's somebody who maybe has lived here, but is of German origin, and you want their bank history from 10 years ago, that kind of stuff. And so the simple extraction models basically will fall apart of that.
Are there more questions in the audience? Up there, two over there.
Thank you. I don't know if I didn't understand correctly. Maybe you can correct me. But if I understood correctly, you're anonymizing documents so that the models can be trained on these documents, for example.
Yes.
And you're using models to anonymize the documents.
Mm-hmm.
So it's which models are trained. So how do you train these models? So how do you train these models which will change the documents? That's what you explained. And then which models are trained on these documents? On some other, so for some other things, not for changing the information, but for some other things. Is that?
Yeah. So you're right. There's two different models, like you said. So for the anonymization, you do have to. You can bootstrap the process with public data, but you still have to fine tune on a given data set. and that you have to still do on sort of data that has P2 on it. But once you anonymize those in documents, those you keep for extraction models. So those are separate models for extracting it and reasoning. So it's something like ChatGPT, right? That those kind of models where you typically upload a PDF and have it reason across a document, that you would pass it, those models you would basically, those kind of models are the ones you would basically fine tune on anonymized documents. It's also easier to basically pass around anonymized documents within an organization. Usually big organizations have firewalls around data. It's very hard as a data scientist to get access to data. If you have a subset of data which is anonymized, that makes it a lot more easier in terms of like being able to give data scientists something to work with.
I think there was a question just in front there.
Hi, thank you for the talk. Did you, for the inpainting model, did you train it yourself or was it off the shelf?
So the model itself was of stable diffusion. So the paper came with code. Not very good code, but it was good enough for me to reverse engineer.
But did you fine tune it for your purposes?
Yes.
And were you able to, do you have like one model for all this variety of documents, different fonts, different backgrounds? Were you able to train one model which is able to more or less correctly inpaint in all those cases?
It was surprisingly good. So for example, that a Polish identity document, we didn't train it on Polish identity documents or anything similar. It just did it. And that's probably because inherently it's based on stable diffusion too. And whatever magic, all the stuff it's seen beforehand, it was able to compensate.
Okay, pretty
So
cool.
just the core corpus of what Stable Diffusion 2 had previously been trained on was enough, essentially.
Okay, nice, thank you.
Sometimes when people black out stuff or replace stuff in PDFs, what they do is they draw a black box over it and then they release the PDF and journalists, they move the black box to the side and then we can read it. So how does it work in your models? Because you have to remove it and then fill it in again. Yeah, how does that work?
We operate completely off images. So what you're talking about is basically operating off the PDF layer. So when I started this talk, I said, when you're doing the text extraction, don't trust the PDF layer. Always convert to an image, do an OCR on top of that. And as you're right, sometimes they just black out the box as just an SVG on top of the PDF. But no, we operate directly off images.
Are there more questions in the audience? I would have one question. No, but there's one in the middle. Maybe I can ask mine first. So you replace names with names of similar length, right? You kind of have to. So you kind of leak some information to the original data. Is this a problem that it could then correlate from the length of the name who it could be?
That's a broader problem in terms of generally that there might be enough ancillary text information in the documents that if you paste it into Google, it could reconstruct. So true anonymization is very hard to do.
Okay. Yeah. So,
but that is one of the sort of edge cases around that. But in terms of, let me think. I think that would probably only work if you had a very long name.
Right. So if you have a very long name, then it's kind of obvious that it must be that person, right?
Or someone with a very long name, yeah.
Yeah. Right, there was a question somewhere here. Yeah.
So after the process is finished, you get save data, right? Save images. But it might still look like PII information in there for an IT auditor. Do you have any way to help us when we have this safe data set stored in our company that the IT auditor doesn't say, oh, this is PII? Do you have any markers, for example, that you put in the image to say, hey, this image was manipulated and it's safe?
Oh, you mean like watermarking that's been anonymized? So we don't watermark the images, but we do just have metadata. Because the idea is anything that's in your system, like your processing pipeline, you should have a record how it went there and where. If you're storing it in an S3 bucket and a hash.
So it's not in the image itself.
No, it's not in the image. The image will be a bit risky because, again, the machine learning models may do really weird things. You can do things like try to embed things in the Fourier domain so they're not visible to us. But then again, the machine learning models do see things differently to us.
Good point.
All right. We have time for one more question. Up there.
Hi, thanks for the talk. It's super interesting. I was wondering, how did you decide what data you want to anonymize and what data not? I mean, names, okay, that's obvious, but we also saw financial transactions. So how do you decide what text to replace?
So the financial transactions we needed, because that's what we're training extraction models. In terms of P2 information, so we have a list which was based off name, addresses. We had a list within our company, essentially.
I see. Thanks.